you can get started.
As for the introduction.
Can we see?
As for the introduction, hello everyone, I'm Hengran Zhang from the Institute of Computing Technology, Chinese Academy of Sciences. It's my pleasure to be here to report our work on large language models for that utility judgments. The authors of this work are Hengran, Ruqing, Jiafeng, Maarten, Yixing, and Xueqi. Firstly, I will introduce the background. Retrieval augmented generation or RAG for short enhance the generation process by integrating relevant information retrieved from the external knowledge sources. The picture on the right is an example I took from a RAG website. Given a question, it will retrieve first and then select some information from the retrieval results to answer the question. We know that the retrieval result contains too many documents, but the generation model does not need so much retrieval documents. Moreover, due to the limitation in the semantic understanding of retrieval models, not all documents in retrieval results has utility in answering the question. That means that relevance do not mean utility. So it will select some documents from the retrieval results for better generation. In fact, this selection process is to fill the semantic gap between the retrieval and the generator. Generally speaking, for this selection part, we can directly use the large language models to select the documents based on their relevance to the question, similar to the retrieval model. But for generation, utility is more important than relevance. So relevance is not enough in retrieval augmented generation. Relevance and utility are two different concepts for evaluating retrieval results. Relevance is focused on the degree of topical relevance between the retrieval results and the question, where utility is focused on the value of the retrieval results for the information seeker to answer the question. Here is an example. We have a question. Why do leaves change color? There are three evidence. All evidence is relevant to the question. However, for users, only the second evidence has utility in answering the question. The answer of evidence 2 is more comprehensive and explains why the leaves change color. From the example, we can see that focusing on utility can provide precise evidence for RAG more directly. There are many researchers on relevance judgments using large language models, but there is little research on utility judgments using large language models. Therefore, we conduct a comprehensive analysis of the utility judgments in large language models. First, we formalize the utility judgment task. Given a question and a list of candidate passages, the utility judgment task is to select supporting evidence with utility in answering the question. Next, I will show you our analysis and conclusions. In order to analyze the utility judgments of the large language models, we designed the three research questions. First, whether the large language models can distinguish between relevance and utility. If it can't, there is no need to study utility judgment using large language models. Second, what factors affect the ability of the large language models to make utility judgments? And it can provide insights for future methods to improve the performance of utility judgments. Finally, analyze the impact of utility judgments on the generation in RAG and confirm the necessity of utility judgments. We built two benchmarks for three research questions, GTR and GTU. For the first two research questions, we built passages with different characteristics as candidate passage list to evaluate the performance of utility judgments. Among the input passages, there are counterfactual passages, highly relevant noisy passages, and so on. Only the ground truth passages have utility in answering the question. This is GTI benchmark. For counterfactual passages, we use two different construction methods. For factual questions such as NQ queries, we use analytic replacement method, and for non-factual questions such as mathematical QA questions, we use ChatGPT to generate fluent counterfactual passages. We randomly shuffle the order of passages with different characteristics in the input list. For the third research question, we directly use the retrieval results as a candidate passage list and then studied the impact of utility judgments on answer generation task. This is GTO benchmark. We indirectly evaluate the input evidence by evaluating the answer performance. We select three commonly used open domain QA datasets: NQ, Holopole QA, mathematical QA, and evaluate on 5 large language models such as ChatGPT and Llama. We considered two output forms for utility judgments: set form and ranking form. And there are 3 input forms: point-wise, pair-wise, and list-wise. List-wise had 2 output forms: list-wise set and list-wise rank. Each output form has a corresponding evaluation matrix. For the first research question, we use the ChatGPT to perform relevance judgments and utility judgments, and use the GTI benchmark to evaluate the performance of utility judgments on the list-wise form. We can see that large language models can distinguish between utility and relevance due to the different performance of relevance judgments and utility judgments. The results also show that the performance of utility judgments is generally better than that of relevance judgments on both the list-wise set and the list-wise rank forms, which shows that utility judgments can provide a more precise evidence set. Both mathematical and NQ are single hop question datasets. Mathematical counterfactual passages are generated by ChatGPT, which is smaller than NQ's entity replacement method, so the large language models will be effective when making utility judgments, resulting in a larger performance difference between NQ and mathematical datasets. However, for relevance judgments, both counterfactual passages construction methods are high relevance, so the performance difference between NQ and mathematical is very small. Let's look at a case from the NQ dataset. The question is when did the right to buy scheme start? We can see that the results of utility judgments are more precise, and the passage 9 is the ground truth passage. With the passage 9, the answer generated is correct. Results of relevance judgments are all relevant to the question, but contain some useless passages, such as passage 1 and passage 3. With passage 1, passage 3, and passage 9, the answer is wrong. For the second research question, we analyzed the factors that affect utility judgments, including large language models, input forms, and questions. This part, we also use the GTI benchmark to evaluate the performance of utility judgments. We can see that different large language models show varying capabilities in utility judgments, with ChatGPT standing out as the most powerful. Moreover, large language models of the same family, utility judgments generally improve as the scale increases. Different input forms also have varying impacts on utility judgments. For input forms, list-wise approaches may demonstrate better performance compared to point-wise and pair-wise approaches. For questions, large language models have poor performance of utility judgments on complex questions such as how to procure data sets. In list-wise approaches, we put the passage with utility in different positions. Through results, all the large language models are sensitive to the position of the ground truth evidence in the input list. Different models have different sensitivities to the ground truth position, and there is no consistent trade. However, in real application, information about the positions of ground truth evidence are often leaking. So addressing the sensitivity of the large language models to positions of ground truth evidence is important and requires more attention. For prompt design, we consider several different requirements, chain of thought, reasoning, and answer. Through results, we found that answer requirement is most helpful for list-wise, reasoning is most helpful for prompt-wise, and pair-wise do not need any additional help. So we select the best prompt for each input form, and all the prompts are shown here. For the third research question, we analyze the importance of utility judgments in Rijke. We use the GTO benchmark to evaluate the answer generation performance using different evidence sets. Experiments show that utility judgments achieve the best answer generation performance other than using ground truth evidence. In order to elevate the sensitivity of large language models in the list-wise input form, we proposed a k-sampling method. In order to the original input order, we randomly shuffle the input k times and synthesize the k plus 1 utility judgment results. The k-sampling method has achieved further performance improvement. Finally, I will give a conclusion. In this paper, we conduct a comprehensive analysis of the utility judgments of large language models. We found that large language models can distinguish between relevance and utility. However, the performance of utility judgments needs to be improved in the future. And then we find the key factors that affect the utility judgments. We anticipate that as large language models continue to advance, the influence of these factors on their capabilities will gradually diminish. Finally, we demonstrate the importance of utility judgments in Rijke and propose a k-sampling method for list-wise input forms. So the answer for all this work is that some large language models are good at utility judgments, but utility judgment performance of all large language models need to be improved. That's all my report. Thanks for listening. If you have any question, feel free to ask me now.